Let's consider light. We can't see atoms and molecules, and much of what we know about them comes from the interaction of light with those atoms and molecules. Understand the nature of light. Light can be thought of as both a wave and a particle. We'll discuss its wave nature first. One of the characteristics of light is it has an oscillating electric and magnetic field. So if you have a charged particle in an electric field, it will experience a force. Or if you have a magnetic particle in a magnetic field, it will experience a force. So light will apply a force to a charged or magnetic particle because of its electric or magnetic field. And I've just drawn one dimension. Say this is the electric field, E field. We use a vector because it's a vector field. And one aspect of light that is important is its wavelength. And its wavelength is just the distance between two crests of the wave. And we give it the symbol lambda. So lambda equals wavelength. Another important measure in light is the frequency. We use the Greek symbol nu. And the frequency is the number of crests that pass by us per second. So wavelength has units of distance. And frequency has units of 1 over time, because it's the number of crests that pass by us per time or per second. Now a special unit for frequency is the hertz, and it's abbreviated Hz, and it is equal 1 over second. You might remember a radio station operating, say, at 93.7 megahertz in Oxford, Mississippi. That just means that there are 93.7 million crests of light waves passing by us every second for light at that frequency. There's an equation that equates the speed of a wave with its wavelength and frequency, and we use c for the speed of the wave, and that's just equal to its wavelength times its frequency. So this is the speed of the wave. Now we're talking about light, and so the speed of light would be 3.0 times 10 to the 8th meters per second. So let's find the wavelength for the radio station in Oxford operating at 93.7 megahertz frequency. We'll find the distance between two crests of the wave for that radio station. So we start with our equation, speed equals wavelength times frequency. We want wavelength, so we'll solve for it. That's c over frequency. The speed of light is 3.0 times 10 to the 8th meters per second, divided by the frequency. 93.7 mega is million, so that's times 10 to the 6th. Hertz is 1 over second. And so you can see that the unit second is going to cancel, and we'll be left with meters. So the wavelength is 3.2 meters. And that's about 10 feet. So for our radio station, 93.7 FM in Oxford, the distance between crests of the light waves that it propagates to carry its radio signal is about 10 feet.